if there is any, to having, you know, a computer-controlled system? How does that
Well,
work?
they're able to run multiple trains at the same time on the same track. Okay, so with DC layouts like this one, just direct volt current, if you put two trains on the same track, they're going to run off the same voltage, and if one engine's faster than the other, they actually can crash and bad things can happen. With the digital control, what they've done is they provide them a constant voltage to the train, and then they have digital control inside each engine to control what gets to the motor. So they can actually take multiple trains and make them run the same speed. Even though, you know, the engines are really a little different, they can control them to match the speed and have them run together. Yeah, in fact, the gentleman over here sells some decoders, as you can see. And they're little circuit boards, and they actually receive a digital signal, little pulses, on the voltage of the track, riding on top of the track, very low voltage pulses. And it talks to the, in a way, talks to the decoder and says, and has an address. So each engine has an address. You can say, talk to each individual engine, say, I want you to go at this speed, for, you know, and just keep going. I want you to turn on or off these lights. And it'll do that, and then you can go to the next engine and program it. And so you can actually individually program them all and let them all work together on the same track, but independent in terms of what they're doing functionally. Now, of course, you got to make sure you still pay attention to what they're doing. I mean, you can still crash things, but it really does make it a lot easier to run more and to run more different types of trains together. This is a little simple. Now you can see what Joe did is there's a train on the track. He's running a separate engine, but he's going to have to pay attention to make sure it doesn't run into that one because it will be faster or slower. So you can do it, but it's a little bit more difficult managing.
Turnout's going to be a problem. So again, if you have a lot of track, you have multiple power packs, you definitely want DCC. You can run any train, anywhere, any direction, any speed. You need to unhook those springs, and if you pull up on the spring to lift it off the circuit board, then if it tends to slingshot, it usually goes down inside the motor or onto the table. And the best way to do all this stuff, of course, is with a white bath towel sheet underneath it and an apron so that you don't have to find out those springs. Yes, you can get it from MTL. So once you get them unhooked from the circuit board, you will need to, there's a tab in the front that holds the circuit board locked in place. You need to bend the circuit board up enough to pull it forward and slip it out of there. You will take this.
30 minutes.
I can't slip it out here because it's actually sprung in here. This is a light board.
At the same price as raffle tickets.
You're going to take the new decoder board and slip it in. This is a TCS decoder which has these half rounds. It's universal. The Digitrax decoder board, they made a mistake when they manufactured them, and the one notch is not exactly in the right spot. Unfortunately, you have to file that with the Digitrax one in there. But once you change that, it'll drop in, you slide it into the notches, hook the two springs on it, put it on your DCC programming track, and you tell it to run. It's really that easy. The TCS decoder is designed to be wedged in. They want you to loosen these three screws just a little bit, maybe put a screwdriver in here to split it just a little bit. Man, do not turn that screw more than about one turn, and do not spread the chassis more than the tiniest amount. It really doesn't take almost anything for that board to drop into a Jeep 9 or a Jeep 35. You will have to modify an SP40, and on their website they show you how to do that because they turn these notch posts, or turn 90 degrees, they face each other. You can no longer drop the board in, you have to spread it enough to get it in there. It takes a little modification to get that in. Unfortunately, one hand doesn't talk to the other. But once that's in and that's slid in, they're notched in, the springs are on there, again, tighten the screws up a little bit. Never tighten those up like a wrench, tighten those up to like finger tight and make sure it runs. The reason why for not spreading these up too much is MTL bearings have a plastic bearing on either side of the worm gear that's in here. And those plastic bearings have a little tab on them, and they need to go in the little pockets in the chassis halves. So you don't want to be spreading the whole chassis open to put that in there. Otherwise, you will have to take the chassis apart to make sure that everything's where it's supposed to be and put the other half back on.
before you get rid of that picture, I wanted to point out where those contacts are. You want to make sure that the spring or the little wipers on the motor, the contacts on the motor, do not touch the frame. That will burn out any decoder. If you short the motor wires to the frame, any DCC system decoder, it will burn it out.
How do you know that?
Because I've tried
That's correct. So all those decoders have got specifications. They have motor current specification, short circuit specification. All of those specifications are way above what any Z-scale motor is capable of doing. And those ratings are for the motor. Okay? None of these motors can even come close to doing that kind of current. And they all are protected against shorts, but they all do warn you, that's like an intermittent short. That's not like, geez, my local motor's not running, let me try this, hang on, let me read the manual, you know, it's like in the meantime, it can't take that amount of time and it'll burn itself out. So, make sure that you have the tab, as if you haven't bent the tab anything different, there isn't some flashing on the metal or whatever. This top spring's not a problem, it's usually down in the bottom where the motor speed is there, the connection. This is a Jeep chassis, and I think on their same page they had the, now it's kind of a, it looks great on their website, it really does, but there's like really small clearance on these sides there, so you really got to make sure that you can't get too far in there. They had the, I think they're getting pretty good about this. They use a solid wire. For doing the AZL products, they have a light board on the top that doesn't have a retainer post on it. It only has the 4 mounting slots. There's no retainer, so this board simply slips out of there. This one's wired and soldered in. The light board, when you take this product apart, that's their light board. It has metal clips on the side. You simply take the metal clips off the side, and you're going to solder the 6 wires on as shown in there. You will have to cut the wires that are in the package. They're more than long enough. You do need to put them in the color order that they are on there. These colors are industry standard. They're defined by the NMRA. The red and black are the power packs for the track. The orange and the gray are the motor leads. And the white, yellow, and the blue are the LED, the light functions on there. You don't have to worry about if it's really a light bulb or a LED, but for DCC, it is better to run LED product, which most of everything modern, the MTLs, Jeeps are, and that, but the old F7s are not. They're a light bulb. Those can be converted, HTM products, and Z-Track cells, but it's a light, an LED equivalent for that, and actually gives you a more constant lighting. The other great advantage of DCC is always power on the track, right? So that means A, either your headlight's always on, so you know you got track power, or B, there isn't any lighting, dim, speed, faster. There's always going to be a constant lighting. But the light may not be constant lighting and then flicker free, because you're still getting track power pickup, so you still have the same thing you saw with DC. You're going to see the lights flicker a little bit on there.